my email address is on the bottom if you want to contact me after the session to find further information. I don't think when I did the session this morning I was clear enough. So use that to get in touch and I'll share whatever you need sharing with. So if you're new to CAME, great, we'll let you know what it's all about. But if you're an old friend, someone who's used the materials, it's fantastic that you've come along, and hopefully I'll share something that you might want to become involved with in whatever level. So what I'd like to do is just to get a sense of people's experience and what they're coming with. There are two questions I'd like to ask you to discuss in breakout rooms. And it's to do with your familiarity with the materials called CAME, Cognitive Acceleration Through Maths Education, which were very popular in the first part of this century. They piggyback onto some materials that were some training that was led by Caroline Yates and something called CASE, Cognitive Acceleration Through Science Education. So all I'd like you to do in breakout rooms is just discuss your level of familiarity, if you've got any questions, and then through a spokesperson we'll get some feedback, because really it is a very much a scoping exercise to find out what the level of interest is and to see what support we need to make available. So if you could go into breakout rooms for 5 minutes and just share your level of experience, then when we come back, if you put your cameras on, it's just much nicer. Okay, so if we go into breakout rooms, and if you just pick a spokesperson and just share people's level of interest, if people have got any anecdotes, if people have got any stories, that would be great. So if you just do that for 5 minutes, we'll then get a feel for people's experience and background. There you go.
Yes, CB and Christina, you should have a link to join one of the rooms.
Right. We'll just a couple more minutes for everyone to come back in. Right, there were 7 breakout rooms. Would someone from each room just like to share the kinds of things that were being said and the level of interest? Because the reason that I offered this session was when I did my thing this morning on special needs, I just thought I'll put in a session on CAME because there was a lot of interest in Scotland, and I spent a lot of time, lovely time in Scotland. I mean, so much so my daughter's at university in Scotland, so it's obviously rubbed off. So it would just be nice to get a sense of where people are coming from, because CAME is still around and there's information and ideas that might actually be able to help you with some of the problems that you've got. So can someone from each group just give a flavour of the kind of things that were being said and people's levels of experience, please?
Hi, Alan. I was in breakout room 2. My name's Kerry. I'll wave at you. I don't know if that helps. Hi. Nobody in our group has any experience of CAME before. In fact, we hadn't really heard of it. Some of us Googled it when we signed up for the session, and we really just want to know more about what it is, how you can use it, how it.
Great, I'll start with that. I'll start with a little introduction, and then I'll share the idea of the network, which is for everybody at whatever level of experience. Because I just, before lockdown, we did a project with 10 schools in the Tees Valley, Middlesbrough. Many of them were new to the materials. So that's great, Kerry. Anyone else?
I was in breakout room 3.
Okay, great.
And I did my teacher training in 2000, and we had, like, my first 2 lessons were CAME lessons, but no one else, like, I've used it a lot since as well, but no one else in my group had. The one school has the materials, but has never done anything with them. Right.
Okay. Group 4. Who wants to share something for group 4?
I don't know if I was group 4 or not, but I'll chip in anyway. Similarly, I taught in England in the early 2000s, and I used it there. It was built into the schemes of work. But I have the file in my cupboard still, but I don't think I've used it for over 10 years probably.
Right, great. Group 7.
Yeah, again, I'm not sure what group we were, but there was only 2 of us in the room, and neither of us have ever heard of the materials.
Right. So what I'll do is I'll stop there, because we do have a kind of fixed amount of time, and I'll give you a bit of background, but then I'll share. I mean, I got involved in the science version of the project in 1991. Now, there'll be some people in the audience who weren't alive in 1991, so it shows how old it is. But then I got involved in the maths materials, and I've never, ever stopped using the maths materials since 1997 in lots of different contexts. So I think there's some materials there that are very, very helpful if used to add something different to children's mathematical experiences. There are only 30 activities to be done in S1 and S2 or primary 6 and S1. We're not talking about doing them very often, but they're really quite interesting. So I'm going to share my screen. I'll just give a tiny little bit of background. And so what you have is some materials who originated in some research in the 70s, looking at children's thinking in Piagetian terms. They were developed, two authors, Michael Scher and Mundra Dami, wrote the secondary CAME materials. And the idea is that by intervening in their thinking, you can support and promote their thinking that might actually make them do a bit better. It's based upon the ideas of Piaget and Vygotsky, and there have been lots of peer-reviewed, published studies that keep highlighting that if children have this addition to their diet, they do better. So at the moment, in about 5 years ago, there was a paper published from Tonga that showed an increase in engagement and motivation and attainment in children in Tonga who used the materials. So it's very much something that's quite international. And there's the biggest, probably the area where it's most active is South Africa. And they're using it to work with children in the townships because the teaching is, some of the teaching and some of the curricula are just non-existent. So some of the materials are being used very, very well with township children. So that it gives you an idea of how flexible it is. And I've used it in schools all across the United Kingdom and in Wales, in Scotland and Northern Ireland. So you've got something that's really quite interesting and adaptable that hasn't gone away. And so essentially what you've got is you've got an approach to mathematics. What I'm going to do is I'm going to share a couple of activities that aren't in the original publication that were new, that are kind of new. Rather, in case people came with lots of familiarity, I thought I'd share something new. So what you've got is a context that's familiar with the students. They're engaging and hands-on, they're practical. They do not need to do any writing, although you might want them to write at the end of it or for a homework. There is an activity that most people can engage in that leads to a challenge where the students collaborate together. So there is an element of group work, there is an element of working in pairs and fours. There's reflection that leads to further reflection and insights and applying the problem. And what the teacher's doing is kind of mediating the group work, facilitating the group work and the reflection. So it's very much about oracy, dialogue, discussion, because there isn't really an answer. And that's why you would only do it maybe 4 times a term as a starter to a topic to find out how much they know. So what I'll do is I'll pause in a moment and let people ask any questions. But essentially, they're based around this fact that if you challenge a child with something that engages them, it makes them talk. And if they can talk to their peers before me, then they can support each other, because the language of a 12-year-old is better for a 12-year-old at times than my language. So you're setting up a dialogue, you're setting up group work, you're managing groups. You're focusing on metacognition, which is something that people talk about more freely now. And this is what I and some colleagues use to focus on metacognition. How do you describe your thinking? You need to train it. Teachers need to model it. So in the notes, I'm doing some research myself, looking at group work talk in science lessons with their S2 students. So there's a lot of scope for research with these programs. So in terms of Piaget, we do use his ideas. One of the problems with Piaget is he worked with professors' children in Switzerland, and there are not that many professors' children in Middlesbrough, say. So what he did was he came up with some descriptors, and we found out a lot of children just aren't getting through the levels as he described for whatever reason. And so we use his descriptors to support the children's thinking, and the idea that they must develop their own thinking, they must construct their own ideas, and we're putting them in a situation where we are challenging them. And what this picture is quite interesting, because what it highlights is on the left axis is children's thinking in Piagetian levels. Piaget said all children at 12 would be up here at level 3A. Now, when testing was done in the 70s, it highlighted that the average child didn't get there. And all that Piaget has done is identify the top 20, 30% of pupils that could go to a grammar school or a highly selective school. And he said all children would get there. Now, if you spend any time in the classroom, you realize they don't. Some children are very, very far away from that. And so the testing, and I might have to stop sharing my screen because the next slide might not come on. What the testing highlighted, and I'm just going to stop sharing and just go to the screen, sorry, is if you have a look at this slide, is there is a massive range in Piaget in terms of thinking at all levels. And if you're a parent, you're familiar with these developmental curves for height, weight, circumference, the children develop. And so you've got a similar development of thinking in children. And what you've got is this, say, let's pick it's the age of 6. At the age of 6, the range is as great as it is anywhere. And say at 11, when children are at the kind of end of primary, beginning of secondary, the range in thinking is greater than the range in height if you line them up from the smallest girl to the smallest boy to the tallest girl. The range of children's thinking, not what they know, how they look at the world, is really quite fast. And so what the arrows are showing is maybe at a certain time, because they don't all develop linearly, it kind of rises a bit, then levels, then rises. At this time when things are changing in adolescence, maybe if we stimulate their environment, we might help them get a bit better by the time they get to 16. So that's a little bit of the background. And the way that that manifests itself is this slide. So I'll go back to the slideshow. Is all of the lessons have this design. 3 parts of the lesson. When we're talking about a standard secondary thinking maths or CAME lesson, we're talking about this, that you have 3 steps in the lesson that you would go through, sometimes 2, usually you could get to 3, especially if you're going into S2. There's a context in which the activity is introduced, which I'll show you when I do a couple of activities with you. And that then leads to some maths where you're handling some mathematical relationships. What then happens is you move to the next level, which is where you leave the context behind and you're dealing with applying the thinking, you're dealing with the imaginary aspect of mathematics where you've left simple, concrete things behind. And by concrete thinking, we're talking about the type of thinking that blights politics and society, where they say there's 1 million unemployed, there's 1 million immigrants that are taking our jobs. All of these immigrants will build a wall. You know, all of the things that oversimplify the world we live in is concrete thinking, one-to-one correspondence. Now, the world is far more complex and nuanced and multivariate than that. And so the idea is in episode 3, if the class are able, you can touch up in that. Now, with some classes, you can get there faster and spend more time in there. And I'm sure when I do the lesson that I'm going to talk about called Pencils and Rulers, you'll feel because you could do it on Monday or whenever you've got a class. It's quite a nice one to do. You'll know when it gets difficult, when you're leaving the context behind. And the other idea is the other theoretical underpinning is Vygotsky. You know, this complex transition from internal to external speech shapes our words. You know, the meanings of the words. We represent our own thoughts by talking. You know, and if you talk about them, you raise them to a more conscious awareness, so you can think about them and others can think about them too. So there is a whole focus on Vygotsky and Piaget. So what I'd like to do is I'd like to stop now and just put you into breakout rooms for 5 minutes and just see if there are any questions before we look at some activities. So I just thought, since people aren't that familiar with the activities, if I give you some background, you might have some more questions before we move on and look at 2 activities that you could try next week. They're very simple, they're very low tech. As I said, the children don't need to write, but you might want them to write. Or what will happen in the lesson is something will occur that you can move on to and think, I'm going to do that next lesson. The idea is it gives you a diagnostic tool to decide on what you might want to do next. So if we go into breakout rooms just for 5 minutes, just so you can have a chat and discuss, raise any questions you've got, if you do that, please. Right, okay, everyone. Any thoughts or questions?
We didn't have anything specific from room 4.
Okay, fine. I mean, the reason for doing that is sharing that this isn't just some activities that a couple of people have come up with. They are research, they are peer-reviewed publications, and you get a sense of what is underpinning the professional decisions you're making in the classroom. So that's the reason for sharing some of that background with you, that this is not a kind of a quick fix. It's about an enrichment to their diet that for many children is missing. So that's why I thought if I share a little for like 10, 15 minutes some background, you've got an idea of why the lessons work the way they do. Anyone from group 5 or 6 or 7, any thoughts or questions? Okay, so what happened over the years was the secondary lessons were written, and a kind of whole load of CPD developed from that, because a lot of it is about the classroom management and the management of the learning. So for instance, I did a load of work in Greenock, and it was just fantastic to drive up to Port Glasgow and Greenock. And what you would do is I would say teach one of the lessons, and people would look at it, then they would try it, and we would plan lessons together, and then we would meet 3 times a year sometimes for a couple of years, and we'd explore the activities as an addition to the activities they're trying normally. And and it would be kind of shared reflection, because you're trying to get people to give a view of all children rather than just the children in their school. So if 10 schools came together, the discussion would be really quite rich and powerful. And so what happened then was some materials were written for primary 5 and 6. And then the same authors, and this is where it gets really, I think it's really quite interesting, the same authors did some research with children of 6, 7 and 8. So the same people who wrote the materials that we're talking about wrote materials for 6-year-olds and 7-year-olds and 8-year-olds. And so in effect now you've got materials that cover children's thinking from the very beginning of the school right the way to S2 and S3, because a lot of people use the lessons in S3 because some of the later ones get really quite difficult. So you've got a really interesting suite of lessons that I think secondary schools can use to support all of their children, even the very, very weakest who are working at the level of a 6-year-old. So a lot of special schools have used those activities, children in Key Stage 4 in the special school. So it's really quite interesting. So what I'm going to do is I'm just going to share 2 activities with you. One's called Pencils and Rulers, and I'll do that second because it's harder. And one's called Share an Apple, which is about fractions, which I would do with any new first-year class, just to see what their understanding was. But also, when you see what happens at the end, you'll see where you can go with it. Because I think one of the things that interests me is a lot of children, their understanding is quite shaky. It's not based on any real concrete experience. And if children haven't actually manipulated things, some of their understanding isn't as secure as it should be. And this is a perfect example of it. So I would start by talking about 2 children who are fighting over food and are really greedy and they want an apple. And I would say to one of them, I would say to the greedy one, well, you cut the apple and let your sister pick which she has. And I would ask the class how I could cut this apple. And they would say, cut it in the middle, and I would do that. And I would play devil's advocate, and eventually you'd cut the apple. So you'd say to them, okay, I've halved the apple, yeah? What I'd like you to do is just jot down how you could show what I've done, a drawing or with numbers or whatever. And they would write a lot of different things on the board, and some of them would write, and I'll not switch to the camera yet, some would write the 1/2. So I'd say to them, okay, 1/2 is a half, yeah, that's a half an apple. Where's the 1 and where's the 2? Who can explain it? And they've never been asked to do that before. They've been exposed to fractions from the earliest age, and a lot of it is virtual, and it doesn't actually mean anything to them. And so what you ask them to do is you ask them to try and draw what the 1 and the 2 means. And so I'll switch to my camera, and what you'll get is you'll get a whole load of diagrams that create a really interesting discussion with the children. So some of them will do that. Some of them will do that. Some will do 1 out of 2 bits. And if they have to explain and justify that, they really struggle to do that. And then suddenly with one of them, the penny will drop and they'll say, oh, it's, and so at this point, by kind of sleight of hand, you say, okay, it's 1 out of 3. Is that a third? And I would just stand back and let the class argue, because some children think this is a third because there's 3 bits. And I remember doing this with one lower ability S1 group, where this boy who convinced the class that it was 1 out of 2 bits was a half. And he said it's 1 out of 3. It's got to be a third. There's 3 bits, it's 1 out of 3. And then a bit of an argument. So I looked at him and I could see him thinking. So I said, okay, that's a third, yeah? And then I did this. I cut the other half into half. And he said, oh, now it's a quarter. It was only a quarter when there was physically 4 bits. And the richness of that discussion was really, really quite fascinating and really quite lovely. And so what you then get them to do is this. You have 6 strips of paper and they work in pairs, and you say to them, okay, I want you to leave the first bit. And they actually do this. I think it's really important to do this. The next bit, I want you to fold into 2. The next bit, I want you to fold into 3. And they actually have to do it in front of you. Next bit, fold into 3. The next bit, fold into 2. And 2. next bit folds into 3 and then 2, and then the final bit they fold into 2, fold into 2, fold into 2. And so I put mine on the board, and I say to them, I'm going to call this one the whole one. What should we call this and this and this and this and this? Now I would recommend you try this with any group, with all the children who are struggling, because it's so simple, it's really lovely. And what happens is they get a whole, you get some children just do silly things, they'll call these any names. But usually what you'll get is 2 avenues of discussion. 1, 2, 3, 4, 5, 6. Or some will go 1, half, third, quarter, fifth, and sixth. And when you have a vote and you ask them what is the best answer, they'll say, oh, well, it can't be 2 because 2, if that's 1, that should be 2. Twice as big. For a lot of children, they don't have these practical, proportional, meaningful representations of number. It's just a digit. And so this one becomes 2 because look, there's 2 bits. It's 1 out of 2. It's the half. And this one's 1 out of 3, it's the third. This one's 1 out of 4, it's a quarter. This one's 1 out of 5, it's a fifth. This one's 1 out of 6, it's a sixth. And you say, well, is it? Yeah, because look, it's a fifth one. And then when you unfold it in front of them, you say, oh, you said it was a fifth. 1, 2, oh, it's a sixth. And so then they realize that that one's the 8th because it's because of the way you've done it. But what is really lovely is if they then tell you that this is the 6th and this is the 8th, and you ask them to talk about what they notice and what they've realized, for many children, they start to get a sense of what the numerator and denominator are all about, and that actually a 6th is smaller than a quarter, because they can see it, it's 1 out of 4 bits. And if you've got a whole 1 as a reference point, it really starts to make sense for a lot of children. And what is really lovely is you can start playing around with like this. You can say, okay, here we go. Look at this. What does a third and a sixth and a half make? Oh, it makes 1. Really? How's that? And they can actually see that it makes 1, even though the fractions might not make sense to them, or they're making sense of it. And I think there's a whole load of equivalent activities you could do following on from this activity called Share an Apple. There's another big activity you can do that I often miss with children at the beginning of secondary school. But that's the first activity called Share an Apple. That is one that was done in the primary pack that we think is actually got a really good place in secondary to push the understanding of fractions, and especially this bit at the end. And so what I'm going to do with you now is one that you could do with a lot of children who are struggling with algebra and equations. And I'll just go through that one, then you can have a discussion in the breakout rooms. So that was Share an Apple. It starts with a story of a child in a shop. And I would say to them, my nephew really loves the last year in primary school because they can sell stationery to the other children in the school. And sometimes teachers come up and ask for lots of pencils and rulers, and the head teachers won't allow them to use calculators. So what Samuel did was he came up on the wall with this as a way of reckoning the price of lots of pencils and rulers. So pencils are 10 pence, rulers are 15 pence. Can you fill in the grid to work out the price of, say, 6 pencils and 5 rulers? And so what the children do in pairs is they would fill this grid in. And at one point, I would stop them and say, I wonder what patterns you can see, because I can see some patterns, and mathematics is all about people spotting patterns, and that's what we're really good at. And so you ask them, once they've filled it in, to look for patterns. So when you go up diagonally, you go up 25. Why? Because 1 pencil and 1 ruler is 25 pence. It's always 25. So 25, 50, 75, whatever. Why, when you go down, do you go down 5? Down, you go down diagonally, you go take away 5. Oh, you're adding a pencil, but you're taking away a ruler. Oh, that's you're taking away 15, but adding 10, that's take away 5. And so they'd have this big discussion about the patterns you can spot. And then I would say, well, this is a bit like the quiz, the puzzles my grandmother used to do. And so in the resource, there's a kind of, it looks like a sheet from a newspaper, where what they have to do is use the same thinking to find the missing value. So you don't know the price of the pencils, you don't know the price of the rulers, it's a different price. And so the children have to work it out. So you can let them try this in pairs. This is easier than this one. And they then go, that's 10, because you're adding 5. Oh, that one's adding 8. And then they can say, well, we're going up in 8, so we can work out that one. And this one here takes a bit of time, and you let them fill it in and discuss it. And so you have the discussion about the patterns you can spot. Oh, well, this one's add 4, so that must be 28. This one's, 0 is 20. Oh, that's 10. That's 30. That's 40. And you can say that's 16. That's 12. So pencils must be 7 pence, rulers must be 3 pence. And so at that point, what I would do with the children is I would stop and ask them to reflect upon the patterns that they spotted. And mathematically, how might we write these patterns down? So I would say to them, what does 20 mean we've bought? So 20 equals 2 pencils plus 2 rulers. What is 24? Oh, 24 is equal to 3 pencils plus 1 ruler. Can you spot the pattern? Oh, yes, look. It's going down, it's going up 4. So the next one's 28. It's going up 1, so that's 4 pencils. And no rulers. And I would say, hang on, this is just the same, isn't it? And have a discussion. And then I would also add, my hand's getting a bit tired. Do we need, what could we change this? How could we change this mathematically? Oh, 28 is equal to 4p plus no r. Could we do that? Does it matter what letter we use? Oh, so hang on, we've now got this. We've got 20 equals 2p, I'll move the camera up in a moment, plus 2r. 24 equals 3p plus 1r. Can you see the pattern? I'm wondering if you could solve this, because I know my S3 class are really struggling with this. I think you can solve that using the patterns that you spotted. So what I'd like you to do, those are just 2 lessons that weren't in the original secondary maths, in the original CAME folder. The lessons follow an algebra strand, a data handling strand, a number strand, a ratio strand, a shape and space to that strand. They're the kind of main strands of mathematical reasoning. And so these are 2 extra ones. So they're actually more than 30 lessons now. But what I'd like you to do is just discuss what you think, have a bit of reflection in the breakout room about those 2 activities, and we'll get some discussion, and I'll just share what the CAME network is and how you might benefit from it. So if you go in the breakout rooms and just have a discussion about those 2 activities, because they do work, and I would encourage you to try them with your students, because they really are good fun. Okay, welcome back, everyone. The reason for picking those two activities, I wouldn't hesitate to go into an S1 class and use both of them. It's about engaging, motivating, but challenging children and following those kind of 3 steps, something that's very concrete, contextualize, exploring mathematical relationships within that, and then pushing something difficult, which is the simultaneous equations, which the pencils and rulers does really nicely in these kind of three steps. So that's why you wouldn't do it all the time, because you're going much further, you're starting lower and going much further than you would in a kind of more instructional type activity. So any thoughts or comments or feedback on those 2 activities?
Alan, everyone in our group said that we cannot wait to go back and give those a go. I've just started doing equations with my class actually, and it's going to be brilliant. I might not be able to take it as far as that because they're only P6, but I think it'll be great. And the other 2 ladies in the group said the same, that we cannot wait to go and try those.
I mean, if you can pick that up from a remote Zoom session, that is brilliant. It's trying to get a sense of the engagement and the motivation and the kind of sheer moments of joy that happen. And I think, I mean, I've read a book. Has anyone heard of someone called Stanislav Dehaene? Stanislav Dehaene is a French neuroscientist who wrote a book called The Number Sense. And he's done some, of all the people who've done anything in education with the brain, he's one of the few people I would trust, because a lot of what we say about the brain in the classroom is very tenuous. And he was talking about how important mirth can be and enjoyment for focusing children's attention and creating the right dispositions. And so for me, these lessons, children suddenly realize, and I remember one guy in Hamilton, we did a lesson on equations of lines, and this little lad in Hamilton said, well, I'm no brainy, but I can double and add 2. And that was the equation of the line. And suddenly the whole class just went, oh, well, if he can do it. And suddenly you're saying, well, 4x plus 3y equals 46. You can do that. My higher class, some of them are struggling to do that. Any other comments or feedback? Thank you for that, Kerry.
Our group was just curious to see the updated versions of the resources and know how we get hold of them.
Yeah, that part of what I'll come on to that next. And part of it is a lot of it, there isn't really that much of a need to update them, because they work, they're simple, they weren't dependent upon worksheets. Yes, there's colourful more stuff that works electronically, which I'll share with you through the network. But essentially, it's something about a mathematical adult in the room interacting with some children. Not little mathematicians, 11-year-olds, because they don't view themselves as mathematicians. They're 11, and we can shape and form them to seeing that they are mathematical. So I think that's part of it, and sometimes it's sometimes nice to do something where they don't do any writing, or they do a little bit of writing, or they do it later, or they do it for homework, or they reflect upon it. So that he was called Stanislav Dehaene. He's a French neuroscientist. It's called The Number Sense, and it's really quite interesting. And he talks about people having an innate sense of number. We are numerical beings, and some animals can subitize, crows and lions, and the stories about how to fool a crow when you want to shoot it and things like that. But we are different, and we do have a number sense. Brian Butterworth has written some interesting maths books about early number work, but the Stanislav Dehaene does a lot of brain imaging of people, of like mathematicians versus blind mathematicians, and the similarities in their brain and the differences, and it's really quite heartening. It's really quite heartening and positive, and you know that there is kind of hope for people. So, any other thoughts or questions based on those 2 activities? There is a Google link with all the resources there, but if you do want to use the resources, I can send them to you. So I'll go back to this. I'll share my screen and go back to the PowerPoint, because what we started to do with the network was essentially a few years ago, one of the authors of the science materials, with him, we set up a charity, and that charity looks at materials like this in science, maths and English. And the development of that, a bit too late, I should add, is this CAME network, where we can give people access to the materials electronically. There is extension activities, there are activities to support special needs. There's more of the special needs ones because of the materials that have been written for primary children, but also the CPD and training opportunities available more so now with the remote access that has kind of facilitated that. But essentially, it's electronic access to the lessons through something called Pressbooks. It's taken a long time to edit that, so that won't be available till after Easter, but they will be there and they will be available to be used and translated. Because some other countries, some schools in Poland, are going to translate the materials. So all the materials will be available because they're out of print now, and we now have copyright, so they'll be made available for teachers who want to take part in the network. And there's little video tutorials and stuff like that, because a lot of it is someone showing you the stages in the lesson because it's linked to children's thinking. And it might be that if you went through it as a pencil and paper exercise, you might get disheartened, because often it happens because of the engagement, and it's better if you do it at the start of a topic rather than halfway through, or to find out how much your children know. I personally find some of the data handling activities and ratio ones really interesting, because it really pushes their understanding of, well, what are we going to do to make sense of the data? Not let's find the average. So there's some interesting spin-offs between the science and maths lessons where the children are being numerate and they're handling data in a way that's really quite powerful. So we've run out of time. Just nice that so many have come to find out what the material is about. So email me if you want to know more. But I'd just like to leave you with these two things as you go back to school and you want to try these. What that I've said has resonated with you, and what are you thinking more about? And I think that's the interesting bit for me, because I mean, next week I could do a lesson that I first did in 1998 and still get as much joy out of it, because it's about, at the right time, making children pay attention to something that's really important mathematically, like the equation of a line, in a way that's meaningful, that leaves them quite high so they can do it. Okay, so thank you very, very much. I hope you've enjoyed it, and I hope I've encouraged you to at least try you've got two activities you can try next week. Okay, so thanks very much. It's been really lovely to share the activities with you. So thanks very much.
Thanks,
Thank you.
Alan.
Thank you.
Thank you, Alan. Thank you very much
Pleasure.
for agreeing to do a workshop today. And thank you, folks. Today wouldn't happen without
No
you
problem.
as participants and delegates. All the videos that are all going to be have been recorded today will be emailed to you in a link once we get them up and everything. Because you've signed up for it, you will get the link. Not everybody will. It won't be made public. And again, once again, Alan, thank you so much for a very enjoyable final workshop of the day.
Yeah. Thanks, everyone. Bye.
Thanks, Alan.
We do have a, you should have got in your, it's just about to appear. You should have got this in your pack, QR code. You can scan it from your phone. If you can take a few moments just to do the conference evaluation, that would be awesome. It won't take too long. My brain's fried. It's a Google form, that's what it is. And so you can scan it, or you can go to the Scottish Maths Council and fill it in. Any feedback would be gratefully received. But again, thank you so much. You make the day as well. And thank you to the presenters.
Thank you for putting this all together.
Very welcome. It's been a while in the making. So it's all come together on the day, and hopefully everybody has taken something good away from the day. Well, there we go, folks. That's the end of the day. You might want to stop recording, Alan.